Integrating the uProtocol we are working on with Rust and ThreadX. So who are we? So Vitech Mobility, we are mostly working on the cloud side of the SDV. So providing or building back-end systems for the connected cars where you can do remote control or remote commands, honk and flash, have the authorization, authentication in the back-end ready. That is mostly where we are coming from, and the tech stack we are mostly familiar with is like the Java Scala ecosystem running on Kubernetes, deploying to the cloud, having Postgres. I really like Postgres, and also some other NoSQL databases. So basically the cloud stack is where we are coming from. We do actively contribute to the uProtocol. So most of the time we are working with this Rust MQTT 5 transport. I will explain what a uTransport is in a moment. That, so to speak, sits on the bridge or on the edge between cloud and on vehicle. So this transport written in Rust, you can run it inside an HPC, inside the vehicle, or you can just run it on the cloud part and get messages and work with those messages you get. So what is a uTransport, or what we are setting, or what we set out to do is basically you have some kind of, I'm not good at drawing pictures. You have a microcontroller like this above, and the uTransport makes sure that you can convert the message to, or convert some measurements. In this case, it's like temperature measurement to, or you put it in a protobuf structure, that is a uMessage, you send it to the transport. So here's one way of the transport to the MQTT broker, for an example. And you have the other part of the transport, it's receiving, so it has a subscription on the MQTT broker, receiving messages, and then doing the dispatching and processing the messages. Those transports come with a transport protocol like MQTT and come with a programming language. In this case, it's Rust. So from a high-level Rust point of view, the transport looks like this. So you have a sending function. This is this arrow. You have a receive function. This is not implemented with MQTT. More with MQTT on this side, you have a register listener. So you subscribe to a topic, and when the message arrives, the listener is called, and you can unregister listeners. So basically, this is the Rust view or the interface definition of what a transport is. And to keep in mind, there's one funny keyword for Rust. It's async. So they designed the interface to be async, which is, so to speak, a way of cooperative multitasking and parallelizing your program. That would be interesting later on, because on ThreadX you have preemptive multitasking, so you have some way, or you need to implement some components to have those async functions executed in this ThreadX context. So what was our motivation? How does it come that a company mostly working on the cloud side now tries to do some embedded stuff, or going down to the RTOS level? So we were at the hackathon in Karlsruhe, and we set out the challenge to basically, when I go back, implement this little structure. So you are working on a microcontroller, have this message conversion implemented, sending the message to an MQTT broker. Okay, in 2025, you cannot really impress somebody with sending MQTT messages, but nevertheless. And we implemented this in the hackathon with the tech stack. Was mainly the basic, the foundation of the ThreadX RTOS. There's NetX, so we wanted to send messages over Wi-Fi. So that is the wireless or the networking stack ThreadX provides. And it's this funny little board, this MX chip. And for the protobuf conversion, we just tried out Nano PB, which works quite fine. This is a C library to do protobuf conversion. But when we did this, there were some downsides. So one downside is the stack available in the ThreadX repo didn't have an MQTT5 client. So, and uProtocol wants to have or doesn't support MQTT3. And there was only an MQTT client. And we didn't have time to port or to write a new one. So we had to work around a little bit to have this working. So we were not completely uProtocol ready or do not support the mainstream or main implementation of it. There's no C support for uProtocol. There's a C++ base classes wrapper, but not for C. And my point of view, the most advanced or the most stuff for uProtocol is written in Rust, which uses this async stuff. But it's based on the standard library. So basically, when you use the MQTT or the UP base classes, you often need a standard library on the system. So basically, you're running on a Linux system and have a glibc there. So you have threads and you have memory allocation, so heap allocation and so on, which is kind of different in an embedded system. So what we came up with, and here's the crap, so we tried to rewrite it in Rust or port it, stuff that we have written to Rust. We didn't have to start from scratch. That was great. So there is previous work on this combination of ThreadX and Rust. There is an article or a GitHub repo from Ferris Systems, which provides a base combination of those two. So basically generating the Rust bindings and have an example application up and running. It uses a lot of, I think, unsafe code. So there was no API fleshed out to work with it. But this is basically, it runs and it blinks and it works. There's also, and that was my starting point from, I think, Sabaton Systems, a guy named Sojan James, I guess. What he did is, I think, based on what Ferris did, write an API and have the spill script ready. And then you work with less unsafe code. So it's nicer to work with this library than with what previously was there. I started with that, and to my complete surprise, I just had a few modifications. It was not done for this board, but I just had to rewrite a few pieces, and it just worked. That was really nice experience, and I thought, okay, can I go further? Then I looked at the peripherals from this board, and you can see there's a small little display. You have some buttons, you have some LEDs, and they all have Rust support. It's great. And I tried to integrate it, and it worked. That is mostly safe Rust, so I'm not screwing up things, and that is where most of the time, or it nearly always worked. That was quite a nice experience to do, but there were some missing pieces. So there's no async support, or there was no async runtime in what was previously there. So you couldn't just use the interface definition of uProtocol. Okay, you can come up with a synchronous one, that's okay. But I wanted to implement the standard definitions, and there you would need an async runtime. There was no Wi-Fi or no NetX support, no bindings for this, so that what we had to do. We wanted to integrate an MQTT5 client, so there are some embedded MQTT clients written in Rust on Crates.io. We wanted to use one of those and not rewriting MQTT5 clients. And the goal was, which I set out to have a completely safe API. So from a user perspective, the code a user had to write was only safe Rust. So all the mistakes that were made or can be made can be blamed on me. So this would look like this is the target architecture we aim for, or we aimed for. It's, you have a board, and on the left side, you have this ThreadX basic primitive. So ThreadX gives you threads, mutexes, semaphores. So basically all the nice stuff. You have on top of it this NetX and Wicked device drivers for Wi-Fi. On the Rust side, you start with the peripheral access crate. So basically that you don't have to manually write all those magic addresses and write pointers there. This gives you a basic abstractions of all this. A little bit more abstractions, like when you have, I think, the pin types for the input and output pins, then you have this, for this specific board, an abstraction layer. That was already there. Then comes the Rust, ThreadX Rust API. So basically a safe way to call ThreadX functions. That is what was already there, but we tweaked a little bit. To use an MQTT client, you would need a network abstraction layer, like something sockets. So the MQTT 5 client, which is out there, is written against this network abstraction layer and not against the NetX layer, because it doesn't know NetX. So we had to port or to implement the traits in this network abstraction layer. Peripheral APIs, that is also what I mentioned, that was already there. And we had to write an async runtime. And we have this. You can try to port what was there for uProtocol to a no standard environment. That is the part where I skipped most of the things. So there's a lot of work and builders and niceties done by, I think, Kai and Daniel and the whole uProtocol contribution. But it can be ported to a no standard environment, but there's work that needs work to be done to actually do it. So I only ported the stuff I needed for this POC. And then when you have all this, you can write applications against using the uProtocol layer and publish messages and get this routing stuff and have all the niceties of uProtocol. So when you set out on this journey, what you need to do is you always need to start with generating bindings to the C code. Rust has this nice bindgen tool where you just throw in the header files of the C code, or actually it's a little bit more complicated, but then you get Rust types and Rust definitions that you can call. This was already done for ThreadX, not for NetX. I did it for NetX. And we polished the Rust API a little bit so it can be safely used. It's not yet polished, so it's not production ready, what I've done here, but I think I made it a little bit better than it was before, nicer to use. So yeah, as I said, we did some bug fixes on this API. We generated this bindings. There is a network abstraction layer which defines the traits, and an MQTT 5 client based on this. I've implemented this with this NetX bindings. I ported, there's a very simple async executor. It's basically blocking a thread. So when you do with async, you always have to await it somehow. And normally it is done in a way that it doesn't block a thread, but here we just block a thread, and if something in the background happens that the future can make progress, we use some ThreadX event flag mechanism to signal that to the thread, and then it goes on. It works very nice, and in an RTOS world, I'm not an embedded guy, so maybe I'm completely wrong there, but if you just have like 5 or 10 threads, and I always came up with like a measurement thread, a thread managing the display, and a thread doing the network communication, blocking them is not a real problem. So you don't have to manage 100 threads or have writing a web server where you have to deal with a lot of concurrent operations. So in this case, a part of this very simple async runtime worked quite well, using ThreadX underwear, so to speak. So the event flag mechanism and so on. Then I've implemented on top of that parts of this UP Rust trait, and there is a UP transport trait for this. I've implemented this UP transport trait for this MQTT client, which is available on trade. So I think it's called mini MQ. I think we will see it later on. And we generated some no standard compatible protobuf structure. So I had to change in the UP spec Rust. No, it's UP base Rust. Also, the protobuf compiler, if you use Prost instead of what is used now, you can get no standard compatible things, which is, so to speak, a lie because they all use VEC, and so they do heap allocations, but okay. it compiles in a no standard environment. So one could build on that or port it. We have to look or see if it makes sense to do it. So looking back at this target architecture, what we actually achieved is we have this Rust binding, the peripheral APIs, there are the runtime, the network abstraction layer, the MQTT5 client. And here I want to say some parts. I skipped something, so I wouldn't claim that I've implemented the full uProtocol stack in this no standard environment based on this stuff. But we came quite far, and I can in a minute I will show a demo of that is actually working. At least I hope. So what is missing? The missing is yeah, what I talked about, this no standard compatible base structures. There is no complete, no standard compatible Rust MQTT transport available, not fully. And since I'm not an embedding guy, I need help. I would need help on how to actually test it. Since it is small, I can just flash it on the device and test it. So it's like 20 seconds turnaround time, which is okay. But normally you should be able to actually write unit tests for that, which is a little bit tricky in this no standard environment because the standard Rust test needs the standard library. But okay, and there needs to be some documentation written. So basically it's not in a production ready state. So how does code actually look like? I will not demonstrate this one. This is one just switching the some displays and saying hello and displaying the temperature. But the nice thing is that here you have this async executor. So you execute and it says block on. You run it on a ThreadX thread. And with this async thing, you can say, okay, wait until a button is pressed. And if the button is pressed and you hold it, nothing happens because you wait till it's released next. And this is a full button press, and then you can update the display like this. So this is a basic implementation or basic usage of the ThreadX or of the async executor. Very simple one, but just that to show that it's working. A more elaborate one, and this I will try to demo, would be this. This is the that we can really send MQTT uProtocol messages. So yeah, this is the code. I will try to flash the device. So I try to flash it. It has some warnings because of some uProtocol. I think some uProtocol attributes are not yet used. So yeah, I could silence it. So it's now flashing the device. Yeah. So here it's starting up. The Wi-Fi thread is started, and it tries to connect to the Wi-Fi. Hopefully it works. It worked some time ago. Yeah, it started. It joined the Wi-Fi and it publishes MQTT messages. It's just the temperature. It has to be divided by 8. So it's connected to the device. It also, there's on the display, you could see that it's also connected to the MQTT broker. And on this side, it's yeah, it's a subscribe example. It's hopefully, maybe you can see I'm not cheating. It's checked out from the main branch of the uProtocol MQTT Rust. So this would run on a cloud side or an HPC side. And you can see without any modification, it can unmarshal the messages and print the value that the microcontroller is sending. Basically, I was a little bit scared because I reviewed Kai's PR last week where he made the checks more reliable And I'm quite faking a bit. So I was wondering why it is working, but it works. So that was really nice. So yes, that is, we come, so to speak, full circle. We have the stuff running on the microcontroller, generating uMessages, publishing data on an MQTT broker, which runs on this laptop, and normal or standard uProtocol MQTT Rust implementation receiving the message. And from now on, you could process it and do whatever you want with those messages. So now I have to come back to the slides again. Okay, so that is the code. It's on GitHub. In the last slide, there's a link for this. You can play around with it. So this is the basic way for this, how this MQTT stuff works. It creates a network and it implements a transport, or it instantiates a transport, waits for the measurement thread to send it messages via a ThreadX queue, and then just send it out. So here you can see the executor block on transport, and this send method, which was the one I showed previously, which was defined in this uProtocol, uTransport instances. So what was the learning? So what did we learn from going on this journey? The most nice thing is that safe Rust just works. So when you're writing this MQTT the client, this is basically all safe Rust. It just works. It's really nice. So all the errors or stuff which got wrong, or which I did wrong, was in the unsafe part of Rust, and that is really complicated. Most of the things you have to think about the point, you have to manage pointers, you have to look out for undefined behavior when creating references and so on. And it's especially hard because Rust, the safe Rust part, has a lot of invariants which are very subtle, and you have to uphold them in the unsafe part. For example, with all those, or a lot of ThreadX internal structures use intrusive linked list. So basically you have the structure and a pointer to the next mutex, and the previous mutex points to the struct you have now. But if you take this struct in Rust and you just call a function with this struct, it moves in memory, and that would break nearly everything. And you've written just save Rust. So you have to pin it, and you have to move your way around those things, and you have to be very careful when writing this unsafe Rust stuff. But once you get it running, it really runs nicely. It still runs. Yeah, luckily a lot of smart people have written about all those problems. Very nice to go deep into this rabbit holes of pointer provenance, of the stuff they did with that, how to verify it. It's very nice, but keeping this all in mind and working with it and making no mistakes is very hard. There's also, you need nice things on the atomics, how those are implemented, because I took the liberty in looking at the standard library and how they did it for the standard Rust part, and then I ported some structures to the ThreadX. So I'm not coming up with all those things. I'm just trying to look at bits and pieces and try to integrate them. And what I fundamentally would say, or was the outcome of this journey, is that I completely agree with one of the Rust contributors, of the Rust maintainers, where he says that Rust enables more people to write fundamental software, and writing such a layer above an RTOS, in my opinion, counts as quite fundamental and low-level software device application development. And even we, coming from a completely different world of cloud applications, it was quite a nice journey to write these things. So basically, with the Rust toolchain, it's very nice to go from the cloud level. You can also write cloud applications in Rust to go deep down to the embedded level. And as a corollary for the SDV, it would enable a streamlined development of on and offboard components, which is one thing we would very much highlight. So the outlook, where to go from here. So one maybe can this take as a starting point to port some other stuff to this environment. Maybe there's maybe to implement a no standard Xeno protocol. There's Xeno Pico, which is written in C. Maybe one could port something to this environment. One can make a uProtocol for small, so no standard devices. One could think about establishing and maintaining like an official Eclipse Rust binding. That a lot of documentation and stuff needs to be done. But we are, we can do it. We volunteer for it with a little bit help that can grow into maybe a nice community. And the code is out there at this ThreadX Rust NetX fork. So you can check it out, try it out. There's a very subtle bug, which is very nice. So currently, I don't think it will work right now, because you have to comment out a line which is not executed, and only if you comment it out, then it works. That is a very nice bug. Maybe I'm writing a blog post if I found out what this bug is really about. So if you know embedded and like riddles, then come to me, we can look at it. So that was all from my side, and I finish with the blank slide, and a big thank you.
I would have a question, which is, when is this becoming a pull request?
To what? A blueprint could be, or an official binding. So with this, there was no change at the project at all, which in my opinion is a very good sign for the project. They have all quite
So my suggestion would be maybe build a blueprint. That would be extremely interesting, I think, for everyone. So one question.
So this is really awesome. I love it. I was just wondering whether you chose MQTT5 as the protocol just because out of personal preference, or whether you believe that this really plays a role in this architecture.
No. Normally, if I would think about a professional architecture, I don't think that this small chip should speak MQTT, but maybe sits beneath some more powerful chip and have a zero copy in memory communication. That would be, I think, the most professional thing. This is just for demonstration and because I know MQTT5.
Yeah. And as a follow-up then, is there a need for bringing uProtocol with a supported transport to this hardware level? What do you think?
That's a good question. If you think about this architecture where you have safety critical components communicating via this zero copy mechanism to some other things, then even on the lowest level, you can use the uProtocol structures. That might work, it might be beneficial, but I honestly do not really know.
I was wondering, am I not, or are you just redoing what AutoSAR has done for it, basically?
Since I've written no specification, there's nothing to do.
No, of course not. No, I mean, if I have this kind of hardware and I want to read a sensor, isn't that what traditional ECUs would actually be used for? And that is totally established, and we provide a way of integrating the AutoSAR world with uProtocol by means of the some IP protocol.
I think this is more, so to speak, replacing what an AutoSAR component is doing. I'm not saying that this is the way to go, just I've built it because it was fun.
But if we want to replace AutoSAR, this is the way to go. That's what he's saying.
That would be a way to go. It's memory safe.
Second, that awesome. And I don't know when, speaking about my own time right now, but later this year, let's have that conversation about a no standard option for the base components of uProtocol, definitely.
Yep, we can do.
So I would say, well, thanks a lot, Jan. And we are slightly late. And that's particularly exciting because it comes out of a hack challenge. I mean, and this could turn into something that is definitely useful for many people. So